We are the Roadrunner Rocketeers.
A lot of us work with Dr. Pineda in the laser spectroscopy and chemical propulsion lab, and then a few of us took his propulsion class, and we reached out to him about potentially having a rocket-based project, a propulsion-based project that we could do for something like senior design. And he heard from a couple of the other professors who are affiliated with aerospace engineering, and then some of the senior design professors, that this project could potentially be a senior design project if there was a group of students who were willing to put in a little bit of the extra work to get the proposal accepted by NASA and then go through all the design review processes that come with that as well. So he reached out to us, and then we kind of all decided, yes, let's go ahead and let's try. We heard back from NASA that our proposal got accepted and that we were one of the roughly 50 university teams selected to compete.
What I make is the avionics electronics. So this basically tells when the parachutes come out and when the charges go off to separate. So these curly wires, these are E-matches, and they go into the charge wells of black powder in order to separate the different sections of the rocket. And then this guy right here is basically like a flight computer, and it basically uses pressure sensors and accelerometers to determine when the rocket reaches maximum height, which is known as apogee. And that's when the drogue parachute, the smaller one, will come out for a dual deploy. And then it's programmable, so we can designate a certain altitude for the main parachute to come out, which we chose around 600 feet for our second subscale launch.
In order to test these before we could actually launch them on a launch pad, we had to ground test them here on campus. So we basically set up the rockets as close to fully assembled as we could, and then we remotely set off the altimeter. And so instead of the altimeter reading that it was at a certain height and had a certain pressure and then released the parachutes, we actually have an app that we can control, and we just let it know when to go off. So the altimeter ejects the parachute, and we test that with different amounts of black powder until we see the rocket separate, and the shock cord, which is this, it's a little it's kind of covered in the black powder, but until it fully separates and our parachute comes out. So until we see that happen, we keep testing. Yeah, so we actually have two rockets here in front of us. They're all kind of taken apart in different pieces. Our nose cone is modular, so we're able to use that for both rockets. The first one only has one parachute inside of it. We don't have the parachute in front of us, but that one only broke apart one time, and then the parachute came out as soon as the rocket hit apogee, so that's the maximum height it could reach. The parachute came out, and then it landed safely. For the second rocket, we actually had it separate 2 times. So the first time, our streamer, which was made by our teammate Kim, this came out the first time to help slow the rocket down and stabilize it, and then on the second separation, a larger parachute came out to help it bring it down safely.
One of the biggest goals that we have for this project is we want to engage, the younger generations that are coming to UTSA and other colleges to encourage them to join STEM and kind of break the stigma that to do something like this, you have to be Einstein and that it's impossible. It just takes a lot of time and effort. But if you're willing to do that, then this is definitely something that you could achieve.